Today, we're going to talk about sets and maps. These two concepts are very easy to understand and straightforward. So today's class is going to be quite easy compared to other class materials. So firstly, what is a set? A set represents the mathematical notion of a set. So it is unordered. And we know that set cannot contain multiple objects, identical objects, right? So a set stores a collection of distinct items, and there should be no duplicate items, all right? We all know about this very well. And a set is highly optimized for checking whether a specific element is in the set. It is called hashing, which is the next topic of our course. We're going to talk about hashing in the next class. But in this class, we are not going to talk about how we can optimize for checking whether a specific element is in the set, all right? And a set, because it is unordered, we cannot access items using indexes, all right? So these four characteristics are set characteristics, features of sets. And we need to talk about set ADT, abstract data type. The functionality of a set is, firstly, of course, a constructor. We need to be able to create a new set S. And there are some basic operations. So we need to know the length of or the number of items inside a specific set. And we need to be able to check whether X is in this set. And we also need to be able to compare two sets and whether they are equal or not, all right? And we also need to be able to add some items, and we need to be able to remove some items from a set. And there are some set operations. So we need to be able to check whether one set, let's say S, is a subset of T, or S is superset of T. And we also want to conduct union operation and intersection operations. And iteration is another functionality we need to implement, right? So in this, from now on, we are going to implement set. However, the set data structure itself is, as I told you in the beginning of this class, is very straightforward and easy to understand. And we are going to combine the set data structure with other structures in the later of this course to solve more complicated problems in the following classes, all right? So this was a brief introduction of set. And let's implement set together, all right? So we're going to implement sets. And although there are much more efficient way to implement sets or maps using hashing, we are going to talk about that in the next class. But in this class, we are going to implement just naive version of sets and maps, right? So we're going to use a Python list to implement sets, all right? So what we are going to do is we're going to define a set class. And the basic operation, the first functionality we need to implement is the constructor. And we could initialize a set object with some items, right? And we are going to store the items inside a list. So this empty list corresponds to empty set, all right? And if the users provide items and initialize this set object, we are going to add these items inside this set object, all right? So this is our constructor. And the next method we are going to implement is contains, all right? This method checks whether this given item is inside this data list. We are going to implement this in this way, self, whether this item is inside the self data list. However, this one is not that efficient. And we are going to make this very, very efficient. We are going to make this O1, approximately O1 in the next class, all right? Using hashing. Okay, and another method we are going to implement is len. It's going to return the length of, or the number of items inside this list. This is very simple. We just need to return the length of the list. And of course, we need to be able to add some items inside this list. And we need to check whether this item is already in this list or not. So if this item is not inside this data list, then we are going to add this item inside this list like this, all right? So we need to check this condition. Another functionality we are going to implement is remove. We want to remove some items from a list, a set sometimes. And there are two cases. The first one is this item is actually inside our list or set. Then we could remove this item from our list. We just use default function remove of Python list here for simplicity. And if this item is not inside this list, then we are going to raise key error. This item is not inside this set, so we cannot remove this item. And another method we are going to implement is called discard. This is very similar to this remove method. However, one thing different from this discard function from remove method is that it does not raise an error. So why do we do this? We sometimes do not want to raise some errors, but just want to make sure that this item is not inside a set. Okay, so that is how we distinguish between remove and discard. And as I told you before, we want to compare two sets and whether we want to know whether they are same or not, all right? And this is our first PPP exercise. I'll give you some method definition. And this means S is inside T.